In this project, we start with the mummy, which is a precious historical collection that spans time and space, and analyze its significance from the historical and cultural level to the biological research aspect. We explore the similarity between the mummy and the cells in microscopic anatomy and the life cycle system.
It's the core and basic unit that constitutes life, just like the discovery of mummies for the exploration of the body structure and anatomy. It has inspired people to scientifically interpret the origin and the end of life, capturing the development in cell morphology in the microscopic work. Not only the BOV group, but even the general public can understand the evolution and the decay process of the life form changes through the tactile experience.
When we visited Chochakwi Museum, we have gained a precious experience through the observation and visual impact. However, how should the BLV group receive the visual experience and cultural transmission brought by the exhibition? In this practice, we aim to give BLV group an equal chance to understand the exhibition through a tactile journey. Touchable models will be provided, telling the story of transformation from macro to micro level, and the cycle in microscopic perspective. We reconstruct the presentation and produce the organized information to make BLV equally enjoy this discovery. At the initial stage, we analyze the significance which should be included in a tactile exhibition for the BLV group. Under the condition of ensuring safety and operability, BLV will experience a changing process more intuitively through physical contact and interaction with the exhibit, rather than by only listening to the explanation from others. We simulated a world that BLV group people currently see by gradually burying the mummy image with tracing paper to emphasize the importance of strengthening the spatial communication rather than presenting visual communication in a tactile exhibition. To support them directly understand the concept, goals, and formation process of the project, we use 3D printing technology to create touchable braille for them to communicate with the objects.
To deeply improve the narrative story, participation, and educational information that a tactile museum needs to be maintained, we analyze the following precedent studies. In this exhibition, these sculpture works inspired by Braille try to create equality through the process of interactive art creation with the blind people. This case is an art sharing project for the visually impaired. It achieves a short-lived equality in the limited viewing time and limited area. In this project, the artwork cell is made of ceramics materials under the reconstruction and the recognition base fragments, showing the life of cells constantly dividing and continuing. Back to the mummy collection in the Chochakwi Museum. Through the analysis and study of ancient Egyptians' knowledge and technology of corpse preservation, DNA, and cellular tissues discovered from mummies and mummified organs help modern technology continuously update and lead the field of microanatomy to an advanced level. We discovered the strong bond between mummy and modern anatomy. The way of body preservation by Egyptians contributes to the development of the modern anatomy through their wisdom. We scanned the mummy coffin collection in the museum to try multiple opportunities in the frame transformation. Combining the morphological and multi-layer properties of a mummy coffin, cell layers, process of growth and division echo the characteristic of a mummy coffin. As the time flows, the mummified body with preservation will still gradually decay. In a reversed way, the nucleus from the nature will experience a series of evolution to finally become cell. A cell division brings life into a complete form. The layers of mummy coffin and the layer of cells in microscopic anatomy have strong similarity and correlations. Cell layers refer to the relationship between the mummy coffin layers. Understanding the layers of a human cell will help us simulate the research of the origin of life. We found the similarity between the orange and mummy coffin. The pulp of the orange is protected by its pith and peel, which is similar to the mummy, is enfolded by the multiple layers. Therefore, we scanned orange for frame and form testing to try different opportunities in the form presentation. By physically peeling the orange, we experienced a similar interaction with anatomy process in order to break down the orange forms in different stages. Using laser cutting technology, we present the section of orange layers and simulate the mummy preservation method with orange and fruit and other vegetable slices to build up a conceptual layering state. As the conceptual model of reconstruction, the preservation method of dehydrating orange slice refer to the solution of the mummy preservation. We present a series of wire patterns to express the state of the cell layers. They could be spreading from center to surface, following the specific order or randomly arranged.
In this session, we will explore the key narrative story and educational information about cell evolution and motion as time flows, and conclude the significant transformation as the final tactile exhibits. The cyclic life process constantly witnesses the beginning and end of life. We will record the motions of the cells in both phases. From the analysis of motion studies, we understand capturing each movement of motion could easily tell the overall path of action and movement of smaller forms. The decomposition and reconstruction will bring people a continuous narrative experience and a clear understanding of the state of each part in the movement trajectory. As the research of organism and cell, it is a transformation from macro to micro anatomy. This research clearly explains the hierarchical relationship in the human body, especially in the cells. We explored the specific dynamics of cell during decay in this research and recorded the status difference. Here are the cases of cell death in microscopic perspective. We captured a series of bubble models to express a conceptual decay process of cell. It simulates the random sizes of cell in different parts of a human body.
At this stage, we will focus on improving the details of following aspects of the tactile exhibition for the BLV group. For a consistent presentation, narrative stories will be told to the blind group through exhibits of different techniques and presentation representing different forms of cell. Recyclable, natural, and sustainable materials will be fully used in each of the exhibits to ensure the sustainability goals. The process of the cell decay and formation will guide the BLV group to understand the science knowledge of microanatomy through practical contact and interaction. Here's our workflow guide map showing from the initial concept to the final manipulation. On the next level, technologies such as 3D printing, laser cutting, and handmade craftsmanship will enrich the materials and layers of our design exhibits. Surface bulges, plane depressions, and the morphological change will represent different meaning during cellular changes.
Our final design will focus on the changes in cellular decay and the cycle of life. The morphological changes in which cells decay will be embodied in the process of dehydration. The cell cycle generation process will be represented with different movements. People in ancient Egypt preserved the dead body and made mummies since they believed in the myth of resurrection after death. The step of mummification of the body is the process of dehydration. Dehydration is the freeing of water molecules from substances. This series of studies aims to investigate the process of dehydration or decay and to inform BLV people of this phenomenon through analysis and modeling. From a macro perspective, the decay of a fresh apple is a process of dehydration, and the osmosis of the cells due to the concentration difference of the protoplasmic layer are both dehydration processes. According to three special nodes in apple dehydration, made into wooden hemispheres that can be preserved for a long time. The three hemispheres gradually become rough and smaller in size from smooth and moist. The wooden hemispheres are carefully polished and can easily be recognized by blind people. The sanded wooden hemisphere correspond in texture to the three moments of the apple's dehydration. The blind low vision people can be touched by models to feel the dehydration process, so that to understand the principle behind mummification.
According to the cell dehydration, when pressure outside is more than the pressure inside, the osmotic pressure of the cell increased in order to maintain the osmotic balance between intracellular and extracellular fluids. The intracellular water extravastates. There is the cell dehydration process observed under the microscope. While dehydration is lasting, tissues of the body begin to dry out, cells start to shrivel. The movement in cell dehydration is a microscopic representation of mummy dehydration process, while frames show the process that generates cell infiltration due to the difference in concentrations inside and outside protoplasm. By using the CNC and 3D printing technologies, BLV people can directly touch the models to have a profound understanding of the cell dehydration process, the fundamental principle of mummification, and its relationship to modern anatomy. We aim to present the opportunity for the BLV people to physical contact with the dehydration process and discover the microscope world through tactile experience.
We were blowing bubbles on the paper to observe the formation and decay processes. When the bubble bursts, it will leave a honeycomb imprint with pigment on the paper, which shows its mark of decay. A set of recent models were used to record the moment when the fleeting bubble burst. This is another figurative expression of cellular dehydration, so that the blind or low vision people could perceive these otherwise intangible processes. The weight caused by different materials not only figuratively express the process of the bubble bursting, but also show the diversity of cells. When the bubbles form, they will continue to become thinner until they burst. This phenomenon can also be seen as deformation of the bubble caused by the loss of water, the same as the dehydration of cells. The process of this rapid untouchable bursting is presented by this series of models, so that the BLVP can feel this wonderful process.
If the dehydration process is a linear one-way process, then in the follow-up research, we focus on the cycle and the repeat. The bursting of bubbles is a dehydration process, but as bubbles continue to form and burst, it becomes a cycle and a repetition. This series of studies aims to investigate the cycle repetitive process and to inform visual impaired of this phenomenon through interaction models. The process of constantly inflating and deflating the balloon creates a repeating cycle. The greater the pressure, the greater the deformation, which is similar to how cells absorb and lose water. After overlapping the photos of cycling balloons, it presents the movement trajectory of the balloon with an emotional lifelike tension. From the second image, the set of models also indicates a co-living group of cells in the human body. They squeeze and affect each other during the process of hydration to dehydration, showing a dynamic narrative story. The balloons with mesh wrapping are imitating the metabolism of cell and tissue structures. This transition in balloons stimulates a continuous cycle of a cell. BLV people can directly touch this balloon device and feel the circulation process of hydration, dehydration, and the metabolism of cells. In the study of human cells, 3 representative types of cells were selected. By using grasshopper and rhino to stimulate its shape, a series of wireframes and models were generated and 3D printed. 3 kinds of cell models are stuffed into 3 kinds of sponges with different tactile sensations and different densities, which symbolize different human tissues to form the interaction model, cycling sponge. The process of squeezing the sponge to lose water and releasing it to regain its original shape creates a repeating cycle. When the water in the sponge is squeezed out, the 3D printed cell models inside the deformed sponge can be touched. After releasing the pressure, the sponge returns to its original shape and can absorb water again. This transition mimics the continuous cycle of cells from hydration to dehydration. The different tactile sensation of these 3 types of sponges, as well as the small cell balls of different shapes, can enrich audience experience and understand the composition of the internal cells and tissue of the human body from a microscopic level.
The exhibits are physically interactive. We welcome and encourage the blind group to experience the process of cellular change through physical contact with the exhibits. They are located in the entry of the Natural History Collection. We set up 5 exhibition stands that are suitable for the human scale to display 5 series of models. Following the order of our studies, from decay to hydration to cycle and repeat, we will present a clear, safe, and convenient movement trajectory for the blind. Set up blind lens, hand exhibits or place exhibits individually, provide a different tactile and exhibition experience for the BLV group. This is a spatial map for guiding people throughout the level 1 of TAO Museum. The tactile map provides the location of the different exhibition and service areas. Different textures clearly present the different places, accompanied by braille, to make the BLV group easily read this map.
The Sustainable Development Goals are part of a global agenda for achieving poverty reduction and sustainable development for people, planet, prosperity, peace, and partnership through 17 specific and concrete goals. We aim to provide an equal and inclusive art and educational platform so that people who cannot perceive art or scientific knowledge through vision can understand the educational information or cultural meanings behind exhibits through other body perception systems. For achieving the goal of quality education and supporting the BLV, the Braille translation ensures equal access for the blind or low-sighted persons. The exhibition aims to promote the microscopic studies to all learners and presents an equal quality education. Blind land is upgraded to the existing exhibition hall for supporting the blind persons and building a resilient tactile environment. We distribute the scientific and sustainable information for all social audience to upgrade the potential technological capabilities. This tactile exhibition empowers and promotes the social inclusion of disability or other status. It provides equal opportunity of interaction for all social audience and a more equal platform for the blind to interact and learn. Sustainable and recycled materials used to ensure sustainable consumption and production patterns. The awareness of sustainability will be delivered to all social audience to promote lifestyles in harmony with nature.